Let us solve question number 17 from the AP EAPCET 2026 mathematics paper. If the term independent of x in the expansion of x to the power 1 by 3 minus x to the power minus 1 by 2 whole to the power 10 is alpha, then the number of proper divisors of alpha is option 1, 16, option 2, 14, option 3, 15, option 4, 17. Our first goal is to find this alpha, which is the term independent of x. For any standard binomial expansion of the form x to the power p plus a by x to the power q whole to the power n, we can directly find the position r of the independent term using a shortcut formula. The formula is r equals n multiplied by p divided by the sum of p and q. Comparing this with our given question, we have n equals 10, p equals 1 by 3, and q equals 1 by 2. Let us substitute these exact values into our shortcut formula to find r. In the numerator, 10 multiplied by 1 by 3 gives us exactly 10 by 3. In the denominator, taking the LCM for 1 by 3 plus 1 by 2 gives us 5 by 6. Dividing 10 by 3 by 5 by 6 is exactly the same as multiplying 10 by 3 by 6 by 5. Simplifying this basic multiplication, we cross-cancel the terms and find that r is strictly equal to 4. But remember, knowing r equals 4 only gives us the position. We now need the actual value of this term, which is our alpha. Using the general binomial term formula, alpha is equal to 10c4 multiplied by the coefficient minus 1 whole to the power of 4. Since the power is an even number, minus 1 to the power of 4 simply becomes a positive 1. Now let us calculate the combination 10c4. The numerator expands as 10 into 9 into 8 into 7, divided by 4 into 3 into 2 into 1 in the denominator. We can simplify. 4 into 2 in the denominator cancels out the 8 in the numerator completely, and the 3 divides the 9 exactly 3 times. So we are left with 10 into 3 into 7. Multiplying these remaining numbers together, we get our alpha value as 210. Now that we have our alpha, the question asks for its proper divisors. To find this, we must first do a prime factorization. 210 is simply 21 multiplied by 10. Breaking it down further into prime numbers, it becomes 2 to the power 1 multiplied by 3 power 1 multiplied by 5 power 1 multiplied by 7 power 1. To find the total number of divisors, the mathematical rule is to take every exponent from this prime factorization, add 1 to each exponent, and multiply them all together. Here we add 1 to each power of 1. This gives us 2 into 2 into 2 into 2, which equals 16 total divisors. However, the exam specifically asks for proper divisors. The total divisors include the number 1 and the number 210 itself. To get only the proper divisors, we must subtract those 2 improper divisors from our total of 16. 16 minus 2 leaves us with exactly 14 proper divisors. Going back to our original EAPCET question and looking at the given choices, we can see that 14 perfectly matches option 2, and that is how you solve it quickly and accurately.